Hey, good morning guys. I wanted to put a quick video out of the steps required to name ionic compounds and to write formulas for ionic compounds. So I've provided you additional practice in the form of this worksheet that we're looking at here. There's also a key for all of the problems. So let's go ahead and let's first take a look at the steps needed to take our formula, such as MgS, and write our name, such as magnesium sulfide. So we actually have three different instances. We have our quote-unquote regular ionic compounds, if we look at number 1. We have our ionic compounds that have polyatomic ions, if we look at number 2. And if we look at number 5, we have our ionic compounds that include transition metals. And it is the same three basic steps that we are going to utilize to name all of these different types of ionic compounds. So let's take a look at our first step. So our first step, we are going to name the cation. Okay? There is a certain circumstance where we have to include Roman numerals, and that would be if our cation is a transition metal. So we need to name the cation, include Roman numerals if transition metal. And remember, our transition metals are in groups 3 through 12. Okay, so let's look at number 1 and let's complete that first step. So for number 1, our cation is magnesium, and we know that because it's out front. We know that because it's a metal. We know that because it's on the left side of the periodic table. So let's just go ahead and write magnesium. Okay, that's our first step. Our second step, let's see if we can get this in here, and I apologize, it's not in order. I'm trying to just utilize my screen as most I can. Number 2, we are going to name the anion. Okay, and again, we have a couple different types of anions. We have our quote-unquote regular anion, like sulfide, oxide, nitride, but we also have some polyatomic ions. So we are going to name the anion, and if, so I'm going to say right away, if that anion is polyatomic, we can stop here. Okay? If it's not, we need to then change the ending to IDE. So let's take a look at number 1. Well, we just have one letter, so it is not a polyatomic ion, so we need to continue. So we have magnesium, sulfur, right? The S represents sulfur. But now, since it's not a polyatomic ion, we need to move to step 3, and we need to change the ending from sulfur to sulfide. So number 1, we're looking at magnesium sulfide. Let's see if we can apply those same steps to number 2. So name the cation. Let's look at that first element is Ca. So we look to our periodic table and we see that it is called calcium. We go to step 2, right? Whatever is left over, we've already named our cation. That means everything that's left over, CO3, is going to be our anion, and of course that is made of multiple atoms, so that is a polyatomic ion. So we actually have a big list of polyatomic ions on the bottom of your periodic table, and if we look at CO3, we can see that it is carbonate. So we can stop right at step 2 because this polyatomic ion is a polyatomic ion. So calcium carbonate. Finally, let's look at number 5. Right? Number 5, name the cation. Well, Cu, we go over to our periodic table and we see that it's copper, but let's take a look. It resides within the transitional metals. So what we're going to have to do is include a Roman numeral. So how do we do that? Well, first off, we need to know that that Roman numeral represents the charge of copper, not the number of atoms. So it is not copper 2 because of that number 2, but instead let's take a look at what it is by utilizing the reverse cross of charges. So that 2 was originally the charge of sulfur, And since we have no number outside of sulfur, that means it was a 1. So the copper's charge is copper 1. Okay, and all of the steps from here remain the same. So let's look at what's left. It's just S, so it is not a polyatomic, so we're going to say sulfur, and we need to move to step 3, so sulfur becomes sulfide. So we have magnesium sulfide for number 1, calcium carbonate for number 2, and for number 5, copper 1 sulfide. Okay, and those are the steps that you are going to utilize to take formulas and create names. Let's take a look at what we need to do to move in the opposite direction. So on the second page here, we can see, again, we are being asked to create something for an ionic compound, except this one, it's a little bit different. We want our formula. So again, we have 3 different types. We have our quote-unquote regular, we call them binary ionic compounds. We have our polyatomic ionic compounds, and we have our ionic compounds with transition metals. So we're going to look at numbers 1, 19, and 27, and let's throw some steps down. Again, we can utilize 3 relatively simple steps. Let's put those down. So step number 1, we are going to write the formula for the cation. Okay, and this is going to be the same regardless of what type of compound it is, just where we're getting those numbers might change. So for number 1, we are going to look at magnesium, again being the first word. That must make it the cation because it's out in front, it's a metal, it's on the left side of the periodic table. So I find magnesium on my periodic table, and I go up to the top, and I see that magnesium has a 2+ charge. So I write Mg 2+. Notice it is the formula for the cation, not the uncharged neutral atom. So we need to include that 2+. All right, number 2. Our next step, we need to write the formula for the anion. So whatever's left, in this instance it's oxide, we need to find it on the periodic table. So let's head over to the periodic table and find oxygen, because remember, we have changed our ending because now it's an ionic compound, and we look to the top, and oxygen also has a charge of 2, but it is -2. Alright, so let's write those up there, and let's look at our third step. Our third step is going to be cross charges, and this is kind of a multiple part one, and rewrite with no superscripts. Those are the numbers up on top, or number 1s, right? We don't want any 1s in there. So we can take our 2 and we cross it down. We can take our 2 and cross it down, and we're going to rewrite this. So if you were just to rewrite this, it would be Mg2O2. But if we notice, we have a 1-to-1 ratio. So instead of Mg2O2, we only need 1 of each. So we would rewrite that as MgO. So magnesium oxide is written MgO. Let's see if we can use these same 3 steps to solve problems 19 and 27. 19, chromium 3 oxide. So here we have a special instance where we have a transition metal. We know that because of those Roman numerals, and chromium resides again within groups 3 through 12. So this is a transition metal, but look, the steps are the same. Write the formula for the cation. Well, Cr plus 3. I'm getting that plus 3 from the Roman numerals, not the periodic table. Next step, write the formula for the anion. O minus 2. We just did it in number 1, but if we wanted to do it again, we'd go to the periodic table, we'd go to the top of oxygen, and we see it's -2, and finally, we cross our charges and rewrite with no superscripts, no numbers on top, or the number 1. So the 3 from chromium comes to the bottom of oxygen. The 2 from oxygen comes to the, the 2 from the top of oxygen comes to the bottom of chromium, and we rewrite it as Cr2O3. Chromium 3 oxide. And finally, if we look at number 27, we can see calcium acetate ends in an ATE, and it's not an IDE, okay? So this is a big giveaway that this is a polyatomic ion, right? Polyatomic ions are going to end with ATEs and ITEs 99% of the time. But we're going to still use the same 3 steps. So calcium, write the formula. It's Ca, and its charge is 2+. So I find it on the periodic table. I go to the top. It has a 2+ charge. Now acetate is not going to be in the periodic table because it's a conglomerate. It's multiple atoms together. But fortunately, you guys have a periodic table that has a bunch of these common formulas for things like acetate and other polyatomic ions. So let's go ahead and zoom in and let's see what we have for acetate. Well, acetate, whoops, excuse me on that. Acetate, we can see, is our first compound there. So what are we going to do? We're going to write the formula for the anion. So we can see it's C2H3O2 minus 1. And now when we cross charges, I'm going to tell you guys a little hint that makes my life easier. I put all of my polyatomic ions in parentheses. So when I cross my charge, it gets put in the right spot. We want that 2 to be on the outside of the parentheses, indicating we have 2 of everything inside there. And what we end up with is, I'm going to bring this down a little bit, Ca parentheses C2H3O2 and a 2 on the outside. Versus if we didn't do the parentheses, so again, this is going to be the correct answer, but if we didn't utilize those parentheses, what we might end up doing is bringing that 2 down and saying we have 22 oxygens. We don't want 22 oxygens, right? So this second way is not the correct way. We want to utilize those parentheses. So if we look at how to name these compounds given the formula, we can use 3 steps. If we go back to the beginning and we want to write formulas, we also have 3 steps. So go ahead and use this for some practice. Check your work against the key, and if you have any questions, as always, reach out and I will get you help almost immediately. Okay? Enjoy the day, guys.